Imagine asking an AI to find a very specific atmosphere. You aren't just looking for a cafe, you want a space that captures the scent of rain and the quiet of a storm. Traditional databases are built for rigid, binary logic. They look for specific keywords. If a file isn't explicitly tagged with those exact words, the computer sees nothing because it cannot perceive a vibe or a sensory concept. AI translates human meaning into math, creating an embedding vector, mathematical coordinates mapping a prompt's features into multidimensional space. But comparing one coordinate string against billions of others triggers immediate system overload, stretching search times into hours. For AI to work in real time, it needs a way to bypass the crowd. It requires a filter that can instantly discard nearly everything in the database to focus on a tiny, relevant fraction of the data. We can visualize this massive database as the concept hotel, an infinite structure where every room contains a different piece of information. When you enter a prompt, the system creates a digital signature. This digital signature isn't just a simple label, it's a high-tech navigational beacon encoded with the exact semantic coordinates of your request. Checking this beacon against every room in an infinite hotel is mathematically impossible for human timeframes. The search would never end. The vector index pre-organizes data into clusters, or floors, grouping information based on shared themes. The index reads your beacon's coordinates to instantly identify the correct cluster, acting like an express elevator that bypasses millions of irrelevant rooms. This is how AI achieves its speed. It doesn't search faster. It intelligently eliminates the vast majority of the world before the search even begins. Now, the search is confined to a single hallway. Every room here already shares the general theme of a rainy indoor space. Standard searches are all or nothing, but vector math is different. It's fuzzy. Your beacon doesn't just match one room, it resonates with several doors in this hallway at varying levels of intensity. This diagram shows approximate nearest neighbor, or ANN. The system calculates the mathematical distance between your beacon and the cluster's data points. By measuring this similarity distance, it scores each result, highlighting the highest alignment as the winner and filtering out partial matches. Replacing rigid yes or no logic with this similarity distance is what allows a computer to finally grasp nuance and context. The system delivers the result that resonated most strongly. Inside room 402, we find the exact rainy cafe atmosphere we were looking for. Engineers call this the top K nearest neighbors, the small selection of data that sits closest to your intent in mathematical space. This is a departure from how we've used computers for decades. We are moving away from the era of rigid alphabetical sorting and binary filing systems. Human beings don't think in spreadsheets or exact keywords. We navigate life through associations, memories, and interconnected concepts. By pairing the depth of embeddings with the efficiency of vector indexing, we've built an architecture that finally organizes information the same way we experience it.